What types of soils are there in Russia? Arctic, tundra, clayey, Podzolic, Sod-Podzolic, grey forest, Chernozem, brown and grey-brown, chestnut. Let's look at some of them. According to official sources, podzolic soils are typical soils of coniferous or northern boreal forests. These soils form in cold areas with good leaching conditions. The term podzol was established in science by Dokuchaev, who studied these soils since 1875. It originated from the local Smolensk province vocabulary and the peasants' shared experience, where the first plowing of virgin land exposes an ash-like soil layer. According to modern understanding, the genesis of podzolic soils is associated with the following biogeochemical conditions. The plant litter is poor in nitrogen and ash elements. Lower temperatures and a leaching water regime, slow microbial activity and the predominance of acid-forming fungal decomposition and the preservation of forest litter in the form of a layer on the ground. Podzolic soils are classified by the thickness of the alluvial layer, which varies from a few to several dozen centimeters. The next type is Sod-Podzolic soils. The subtype of podzolic soils contains from 3 to 7% humus. Among podzolic soils, the most fertile are found in the southern part of the forest zone of the East European and West Siberian plains. Sod-Podzolic soils. Podzolic soils are typical for the zone of broad-leaved forests. When plowed and cultivated, they are more fertile than podzolic soils. They do not have a water-resistant structure and tend to become waterlogged. Grey forest soils. They are formed in the forest steppe zone under conditions of periodically leaching water regime, beneath the canopy of broad-leaved mixed or small-leaved forests with diverse and abundant grassy vegetation. And now pay attention. We need to remember and realize that, according to scientific data, 1 centimeter of soil forms in nature over 250 to 300 years and 20 centimeters take 5 to 6,000 years. Next, grey forest soils are widespread in the temperate zone of the Northern Hemisphere. According to the 1977 soil classification of the Union of Soviet Socialist Republics, they are divided into 3 subtypes: light gray, gray, and dark gray, Chernozems. Geographically, Chernozems occupy significant areas in Eurasia, especially in Russia and Ukraine. In America, the Chernozem zone covers the western United States, southern Canada, southern Argentina, and southern Chile. In 1763, Mikhail Lomonosov's geological work described soils as the Earth's top layer. He also introduced Chernozem to science, applying it to both cultivated and steppe soils. He disputed its primordial nature, showing it forms and accumulates from decomposed plant and animal matter. Peter Pallas put forward the hypothesis that Chernozem originated in the place of former coastal reed swamps. Roderick Murchison supported the marine hypothesis, suggesting that Chernozem came from the erosion of black Jurassic clays. A monolith of Chernozem was presented as a special exhibit at the 1889 World's Fair in Paris. So, soil science is the result of the tremendous work of many scientists from different eras connected to the incredible value of that layer of the earth which gives life on our planet. It is undeniable that soil is formed as a result of the decomposition of the plants growing on it. It is enriched with humus, turning carbon dioxide into plant carbon, and then with bacteria and fungi into soil humus. The formation of soil is clear, but its development is a real problem. Meanwhile, all scientists still overlook these obvious inconsistencies. Here are a few observations. A pine forest near the settlement of Armashovo in the Alapevsky district of Sverdlovsk region. The study site is 4 kilometers from the Resh River and over 20 meters above the water. The bank is steep with no floodplain. What interesting things do we find in the soil? A pine forest no older than 60-70 years. The top 3 inches of soil is covered by needles and cones. Beneath that is a granular layer, 3 less than 1/4 inch in diameter, followed by a 10 inches thick humus layer. Then, layers of fine sand gradually mix with clay becoming more dominant and eventually reach the bedrock. How could something like this have formed? A strong water flow washed away and mixed the clay and organic matter before settling. The lightest material, organic matter, stayed on top. Later, a forest grew and cones and needles fell. The clearly defined upper layers show the soil grows by more than 1 centimeter in 250 to 300 years. The second example is the Kiselovsky district perm cry in the 1960s. Near the city, the vegetation consisted of sparse grass with a complete absence of soil, just bare clay. The forests were mainly represented by spruce and fir in the ravines and birch in the mountainous areas. Areas once lacking economic activity are now covered by 30-40-year-old forests with 1-2 centimeters of soil. The area around Kisel belongs to a region with a cold climate. In the forests, the snow melts after mid-May and frosts are possible in the summer, even in July. After September 20th, snow often fell. That is, the conditions for active humus formation in the soil are unfavorable. In the 1980s, we started a garden in Shakhta village, Perm region, on solid clay soil. To improve the soil, we added manure and black soil, which we brought from a pit near the village of Lunevka in the Alexandrovsky district. Why was there black soil? A thick multi-meter layer had filled the large pit. Now, of course, it's clear to us that organic matter was washed into the pit by some large-scale mud flow, and then it decomposed. To be continued. 2018-2. Near the bypass road in Berezovsky, a pit of black soil was found while preparing land for construction. It held about half the volume of a railroad gondola car, surrounded by loam with a thin 1/3 of an inch turf layer. People involved in farming and household agriculture can give countless such examples all over the northern hemisphere and beyond. They suggest that soil formation was shaped by floods, not ancient biblical ones from 13,500 years ago, but likely those from the 17th and early 19th centuries. These floods, judging by the nature of the soils, were not rapid and were divided into numerous stages and had different sources. Planetary tsunamis, the collapse of the vapor water dome, and the emergence of underground sources to the surface. If it weren't so, we wouldn't have inherited the architecture of past centuries. There wouldn't be stone houses with flooded first floors. Everything would have simply been swept away and mixed together. Instead, we have vast areas covered with clay, sand, and black soil deposits. The soils on the territory of our country are somewhat like surf on the seashore, created by Dima Torzok. Anyone who has been to the shore has seen how the waves sort sand and debris by particle size and density at the water's edge. Everything is layered. In part, that's how our soils were formed as a result of the planetary cataclysm Dobro. From this, we can assume there wasn't much soil variety at first. After the cataclysm, humus accumulated and transitional soils, subspecies so to speak, began to form. In different climatic regions, these subspecies developed at different rates. People keep debating whether these buildings were buried by the flood or originally constructed that way. Actually, the answer is easy to find. We've all seen a pit dug for a building foundation or underground root more than once. Any reasonable person would say that it's impossible to evenly bury underground utilities again so that the different layers match up exactly the same way. If even layers of soil come up to the wall, then it definitely wasn't built that way. That's exactly how the layers were deposited. Assuming there was no flood and the humus layer is building up quickly, we should ask, where are the black soils from previous centuries? Brown and hard coals are a separate topic. Official science believes that peat is a combustible mineral formed in the process of natural dying and incomplete decomposition of marsh plants under conditions of excessive moisture and limited air access. It is customary to distinguish peat from soil formations by its content of organic compounds, which should be at least 50% relative to its absolutely dry mass. Here is the general information. The organic matter of peat consists of plant remains that have undergone varying degrees of decomposition. Humus gives peat its dark color. According to the conditions of formation and properties, peat is classified as raised, transitional, and lowland. It is difficult to agree with this official point of view for the following reason. Study the peat deposit records in the Sverdlovsk region and you'll see an indicator called ash content. It is marked by inorganic components in the fuel, typically silicon, iron, and aluminum oxides. So, according to the records, the ash content ranges from 20% to 70%. However, here's the problem. Plants do not and cannot have such mineralization. The ash content of different types of wood is only fractions of a percent. Shell rock can even be found in the deposit near Gorodishche in Tavdinsky district, Sverdlovsk region. Can you imagine how many thousands of kilometers the mudflow would have had to carry it? If peat were formed the way official science claims, then the ash content of peat would be no more than 1%. Actually, ash content was washed away by the flood along with organic matter. We can now conclude that the flood was either prolonged or recurring. Organic matter from certain areas washed into river valleys, ravines and lakes, settling to form peat deposits. Lighter organic material produced the main black soils. The old pre-flood layer was not washed away everywhere. Under the layer of clay and sand, the old humus layer can still be found. So, an impartial study of soils must inevitably lead any researcher to the following conclusions. The formation of modern soils was influenced by two factors. First, the climate before catastrophic events was much more favorable for the decomposition of the organic matter that grew there before, and soils gained humus much faster back then. And second, it was the flood, which made some soils much richer and others much poorer as a result of the transfer of fertile and infertile layers. The final conclusion from these studies is that soil science does not take into account the results of real, recent global cataclysms, and that's why it is forced to fit its research results to the events of official history, which has no place for the flood of the 19th century.